Good afternoon. I am Swaroopa from Mlritm College of Engineering and Technology and Management. Today I am going to tell about the software engineering. Basically, what do you mean by the software? Uh, Today I am going to tell about the introduction of the software engineering. Software is nothing but it is a set of instructions. When we are going to execute any instructions, it provides the desired features and the reliability and the efficiency. Okay, when you are executing any particular software, that software should be a reliable, flexible, and performance should be a very efficient. And the next, in the software engineering, there will be a data structures. Data structures is nothing but we can modify the information, we can edit the information, whatever we want in the particular software. Coming to the next is basically the computer programs is associated with documentation such as requirements and the design model. And see, first of all, if you want to build any particular product, first we have to gather all the requirements. After gathering the requirements, what we will do, just we have to design a particular model. After designing, just we are going to execute that particular product to get the correct efficient output. That is nothing but a software. That is nothing but a product which consisting of a requirements. The requirements, we have to gather the requirements and we have to design. After that we execute so that we will get the efficiency and the output to that particular product. And the next one is engineering. What do you mean by engineering? Engineering is nothing but whether we are developing any suppose if we are designing. Suppose engineering is nothing but, suppose if we are designing and building a particular product. We are designing the product and we are building a particular product. And the next, it is the application of science, tools and methods to find cost-effective solution to the problems. How we have to design the engineering? Is, first of all, we have to develop any particular product, and that product should be a cost low, and the cost effective. We have to design that particular product. And the next one, the application of scientific and mathematical principles to the practical and manufacture, the efficient and economic structures. See, when you are designing a particular product, it is not only for the scientific research, but also it is used for the mathematical and ecosystems and some process. See, engineering is not only the scientific purpose; it is also used for the economical structures, mathematical structures, and the ecosystems. All this will be comes under the engineering. Not engineering is just we are building a product in a scientific manner. We can also do for the mathematical approach and ecosystems and the process. This is nothing but the engineering. And the next one, what is SE? Means what is a software engineering? Software engineering is a software product will define scientific principles and the methods and the procedures. So SE is nothing, software engineering is nothing but we are going to build any particular product. To that particular product, we are getting the principles, methods and the procedures. See, each and every product, they are having some procedures, methods and the principles. Next, when you are developing a particular product, so that what we will get the efficient and the reliable product. Okay, to get the efficient and the reliable product, we are developing a product, and the outcome of the software engineering should be a efficient, reliable, flexible, and more functions should be get from our product. Is nothing but the software engineering. Software engineering is nothing but the output of the product should be in the form of a reliable, efficient, and it should be a reliable product. And the next one is, see, there are some other SC definitions. There are some SC definitions, software engineering definitions. The SC definitions are which comes under the first definition is IEEE definition. IEEE, how he defined it, it should be a more systematic, disciplined and quantifiable approach. Okay, systematic and disciplined, quantifiable approach. IEEE standard, it has defined as a systematic, quantifiable and disciplined approach. Then only we will get the exact maintenance of the software. Okay, by using these definitions only, we will get the more accurate type of the software of the product. This was defined by the IEEE standard. And one other, the German computer scientist named as a Fritz Bayer defined as software engineering as it should be economical, reliable, and it should be a work efficiently on real machines. It should be all efficient and the reliable machines. The software engineering is establishment. It is used for the software engineering in order to economical, reliable, and work efficient, and it should be able to get the reliable product. Next, evolving the role of the software. The evolving role of the software can play a dual role as a product and as a process. Okay, software can be acted as a product and a process. The product is nothing but it delivers the computing potentials of hardware, and it enables the hardware to deliver the expected functionality, act as a information transformer. Okay, software can play as a two roles, either as a product and or as a process. Means in this we are getting the hardware functionality of the product is nothing but the how the software which getting the evolving the role of a software. It will be deviate in between the two, either it is a product or it can be a process. Okay. And the next one is software as a process. Suppose if example as a vehicle for delivering a product, in this software does not deliver the functionality of its own, rather it helps the creation and control of the programs. See, in this operating system main act as an environment. It will take care of all the whatever the process that are performing in the other products. The operating system will be take care of all this software. Okay, and the next one is characteristics of a software engineer. What are the characteristics of the software engineering? See, software engineering has the following characteristics. There are certain characteristics for the software engineering. The first characteristic is software is developed or engineered. It is not manufactured in the classical sense. See, software is developed or engineered, but it is not manufactured in the classical sense. In the classical sense, it is not manufactured, just it is a developed or engineered. And another one more characteristic is software does not wear out. First one is it is a developed or engineered, and the next one is it does not wear out. See, in the software engineering, the one more thing is it's a custom built product. It should be a custom built product, in the one of the thing of the software engineering characteristics. These are the three characteristics. First one is developed or engineered, and the next one is it does not wear out, and the next one is it is custom built operation, and the next one is software is developed, not engineered. In the both software development and hardware manufacturing, high quality is achieved using good design. See, in the software is developed is not engineered. The high quality should be maintained. High quality of the design should be maintained. See, if we are maintaining the high quality of the design, then only we can introduce the quality problems that we can ensure. Okay, the quality problems will be ensured if there is a good design. If the design is not in a correct state, then we will not get the quality number of problems. If the design is a very good only, then we will get the quality problems only. Okay, by using this only we will get the quality number of problems in the software is developed or engineered. The quality problems we will get in this topic. And the next one is changing nature of the software. How the next topic is changing nature of the software. See, software will be changed by using the so many challenges. Okay, by using the so many challenges, the software nature will be changed. First one is a system software, and the next one is application software, and the next one is engineering and scientific software, and the next one is embedded software, and the next one is product line software, and the next one is web applications, and next one artificial intelligence software. See, the system software is just like a compilers, interpreters, all those. And application software, whenever we are developing any particular application, to that application a particular software is developed to that application, and we are going through that software. And the next one, engineering and scientific software. See, in a scientific purpose or any mathematical algorithms, okay, or else any ecosystems, this engineering and the scientific software is used. And the next one is embedded software. Embedded software is nothing but whatever the devices that we are using, for that device software we are using this embedded software. And the next one is a product line software. See, whatever the products that are using in our home appliances like a washing machine, all those, that there were also inbuilt some software is developed to that software. A product line software is also developed to that. And the one is web application. Web application, whenever we are developing in a particular apps, to that a separate software is developed for the web applications like JavaScript and the HTML, all this. For this we will use the web application software. And the next one is artificial intelligence software. Artificial intelligence software means, see, suppose if we are without, in the case of the humans, only the machines will do that particular software. Okay, without machines, only systems will perform the AI software. Okay, without machines, the only system will perform the AI software. Okay, gaming purpose also we will use the AI software. In the place of a human, this artificial intelligence software is used. These are the challenges that we used in the changing nature of the software. Okay, system software, application software, engineering and scientific software, embedded software, product line software, web application software, and artificial intelligence software. This embedded software is mainly used for only in the devices. Whenever you are using the devices, this product line embedded software is used. Okay, all the whatever devices, only for the devices this embedded software is used. These are the challenges that we taking upon the changing nature of the software. And the next one is the types of software. The types of software. What are the types of the software means? The system software, application software, engineering, and the scientific software. System software is nothing but it's a collection of a program written to service other programs. Okay, it is a collection of the program. It is written to service other programs. Is whenever systems are used, by using the compilers and interpreters only, we can run or generate the programs that is used for the system software. Application software means it consisting of a standalone programs developed for the specific business need. Okay, it consisting of a standalone programs that is used in the application software. And the next one is engineered and the scientific software. Engineered in the scientific software is nothing but there will be a scientific areas, okay, scientific approaches like computer aided design and the systems simulation. We use this engineering and scientific software. These are the three types of the software that we used for the first one is system software. Example, we use the compilers, editors, and assemblers. Application software, we can use the standalone programs like database systems. And the next one, engineering and the scientific software. In the engineering and the scientific software, the main example that we used in this is computer aided design and system simulation. These are the examples that we go for the engineering and the scientific software. And the next one is legacy software. Legacy software. What do you mean by the legacy software? Legacy software systems were developed decades ago, being continually modified to meet changes in the business requirements of the computer platforms. See, this legacy systems are very older and a large complex computer. Okay, this legacy software that will be used in the previous days. This legacy software is used for the computers, which means it was outdated technology. That what we are using the legacy software means previous in the older systems they will be used in the legacy software. And this type of systems may include older hardware, software, process, and procedures. See, this for the example of the legacy software is ATC, that is air traffic control system. Okay, whenever in the air traffic control system, this legacy software is used. This was used in the previous days, olden days, and this technology is also outdated technology that is used in the legacy software. Present new technology was developed, but this legacy software is used in the previous days, olden days, for the ATC, that is air traffic control systems. And the next one is, last one is software myths. See, software myths. What do you mean by software myths? See, is the software is myths is nothing but erroneous beliefs or some misbeliefs in the software industry about the software and the process that is used to build it. Some incorrect beliefs. This comes under the software myth. There are the kinds of myths related to software, that is management myths, customer myths, and practitioner myth. myths. Okay, these are the 3 types of the software myths. Okay, management myths and customer myths and the practitioner myths. See, this erroneous is nothing but wrong or incorrect beliefs. Okay, wrong or incorrect beliefs or some misbeliefs in the software industry. Okay, this is all about the introduction of the software engineering and some of the few topics that have discussed you about the introduction of the software engineering and what are the myths, all those. Thank you.